In this video, we're going to have a look at using differentiation to help us with integration, because we know that integration is just the reverse of differentiation. So we're going to use the rule on the top right side here that if y is equal to ln of a function, then dy by dx is equal to the differential of that function divided by the function itself. So what we can see in my example is that I've got a function divided by a function. Now what I'm going to have a look at is to see that if my numerator is the differential of my denominator, then I can work myself backwards using my rule that I just mentioned to get the answer for this integral. So let's have a look at just y is equal to 2 cos x plus 3. Now, if I differentiate this, I get dy by dx is equal to minus 2 sine x. Remember that cos x differentiates to negative sine. Now, this is quite similar to my numerator, but it's not quite the same. So what I'm going to do is I'm going to rewrite my fraction, and I'm going to have it with the minus 2 sine x on the top, because I know that that is the differential of the denominator. Now, because I've added this negative 2 in, I'm going to multiply everything by negative a half. Because what I've now done is I've made sure that the fraction is equivalent to the original question, because minus a half times minus 2 is just 1. But my fraction itself is in the format for me to use the rule that I need to. So what I'm now going to do is if I work my rule backwards, this negative a half that is on the outside of my integral is going to stay. And then I'm going to get ln of f of x. And in this case, we said that f of x was the denominator of my fraction. So that's going to be 2 cos x plus 3. And you can check this by working your way backwards. So our check could be if y was equal to negative a half ln 2 cos x plus 3, then dy by dx would be equal to negative a half multiplied by negative 2 sine x all over 2 cos x plus 3, which does simplify down to sine x all over 2 cos x plus 3, which was what our question was. So we can always use differentiation to help us with our integration.